today we'll be talking about different questions you have on data science. And our guest is Valentine Mwangi. Valentine is a data science curriculum designer. He works with Moringa School to design the curriculum. Also, he's the program lead for AfterWork. Yeah, so I think I can give him the opportunity to continue.
Yeah, maybe you can get started. I'm ready to go when you are.
So one of the questions that we had was, how do you start in machine learning? Like, where can you start? Not machine learning, in data science. Where can you start to become a data scientist? What is the path to take?
Okay. Thanks, Bethany. Hi everyone. And welcome to this chat. So just before I answer that question, I could just introduce myself, then dive in directly into the question. So yeah, my name is Valentine Mwangi. I'm a curriculum designer, more specifically data science. When people think about curriculum designer, they think this person went to school to study how to teach, but not really. I started off in software engineering about 4 years ago, then slowly shifted to the edtech sector, where I started working on more, crafting courses towards data. As a software engineer back then, I used to work with data, creating electronic medical record systems, which were the systems that you usually find in hospitals. So from the knowledge that I had acquired from working with that kind of data, I sort of started working on now how do you now create courses or learning experiences which would allow you to learn more about how to handle data, how to analyze, how to help an organization get value from data. So immediately shifted into that, and since then, for about 3 years, I've been more leaned towards creating learning experiences for data science related courses. So yeah, I have worked for different institutions, from the African Leadership University to ALX to Moringa School, which I'm working at, and I'm also working on a different initiative, which is the AfterWork Data Science Program, which is also more of a data science program tailored towards working professionals. How do you get started with data? You may ask. How do you start, learning how to analyze, how to just first of all learn the fundamentals. After the fundamentals, sort of start working with data sets. Then go into just basic analysis. Then go into the sort of more complex realm of data science. So the first thing that you got to have is, got to have passion. Just like any other job, if you want really to excel in data science, you first of all need to have a passion for solving problems with tech, and also a passion for just learning whatever comes your way, especially with regards to tech, with regards to say the different tools that are available and available for you for your analysis. So I would say, first of all, you would start probably with learning the fundamentals of maybe how to analyze data. I would say, if you wanted to really become a really good data scientist, first start with the basics, the fundamentals. And by basics, I don't mean the programming basics. I just mean how to analyze data. Even if it's analyzing data with Excel, once you get a hang of analyzing data with maybe spreadsheets, then it becomes easier for you to shift into this more sort of complex realm of data science, where you now have to construct machine learning models. You have to go into big data. So if in real sense, I would tell you, maybe start with interacting with data sets. once you get a data set, what do? You try and learn about that particular data set. Maybe it's from a glossary, maybe it's from the background information about that data set. Once you learn from that, can you clean it? Can you clean the data set? But just using the basic tools, even if it's Excel, can you use those tools to clean data? What aspects of cleaning data would you use in that particular situation? Then once you get a hang of that, you get into visualization. You sort of learn the core principles of visualization when it comes to visualizing. Why you start sort of to understand, okay, what's the best visualization to use for certain kind of data that you have. Why not, why is something like a pie chart not the best visualization in most cases? So you move away from visualization, then you move on now into into now something of analysis, creating pivot tables. So you're just learning first by using the basic tools that you have for analysis. Once you do that, you can now be able to progressively move from those tools to other tools, which are now the tools that are normally regarded to as the popular ones, and the to go to if you wanted to become a data scientist and you wanted to solve big, you wanted to solve problems from big, when you have big data sets. That's when you start moving into Python, you're moving into R, you're moving into these different kinds of languages, maybe Scala. So my thought, it would be just first of all learn the fundamentals of how to analyze data with just the tools that you have. Once you do that, when you learn these other tools that you learn later, it would be a lot easier for you. I think when it comes to data science overall, it's, even the definition of it, it's usually using scientific methodologies to solve, data, to solve problems with, data. So what really matters in data science is that you solve a problem that a specific stakeholder has. And if you solve it through the use of R, it doesn't really matter to a stakeholder. What really matters is that you're able to get them the insights that they need in order to make those critical decisions that they want to make. So it's a whole lot of, when you break down the whole problem, or the sort of root cause, you realize that, when you're starting out, it does not really matter the tool that you're using. What really matters is just the ability to apply the fundamentals with any tools that you have. I personally talk to data scientists, and most of them, they tell you in an organization's, even an simple Excel, sort of program, or even Google spreadsheets will do the trick, because what you need are just insights.
Thank you so much for the insight. So you've spoken about how you need to know data analysis, how you need to know data visualization.
Yeah.
So where do you get these skills? Is it through books, tutorials, doing projects, and which specific one?
Yeah. Okay, I would say, first of all, the first stage of any data science project is, first of all, to understand. Then once you understand, you source for data. In order to get insights from that data, you probably need to, first of all, know exactly what you want to do. If it's you realize that you have a big data set and you need to find a summary of a certain period of time, what you would do, assuming that the best tool that you have at the moment would be Excel, and you're not sure what to do, Google is your first, to go sort of place in order to get a way of doing. Sometimes some of these projects, when you get a project and you're not able to do, you can't recall so many things, the first thing you do is Google. And most of the times, if you Google on how to do something, it will direct you to a website or a resource like Stack Overflow, where you'll get a community of similar data scientists who have also, come across such challenges and, have been able to solve and share their solutions. So Stack Overflow is one good place, especially if you are a beginner and also if you are an advanced sort of data scientist. I think most of the times you learn from projects. Projects are basic, and I think work experience. So you could always figure out if you're in the domain that you are in and you want to learn data science in order to enhance what you're doing, the best place is maybe you could start with a simple course, but of course a simple course, maybe online or offline, may not necessarily provide you the tools that you need to tackle a project. So what you would do is just Google around. But I think in terms of maybe if you want to start learning, I would say it usually varies with persons. And I usually tell people, if you want to start learning, just sit down, look at what exactly is your situation, and sort of do a planning sort of an analysis and a sort of a planning, process. So you can also always think about, okay, can I use a tool like what is usually referred to in problem solving, an issue tree, where you look at an issue tree is, if you think about it, it's more like a tree diagram. So you sit down, you're like, okay, do I have resources in order to be able to learn data science? Then you sort of draw a resource, an issue tree. You're like, okay, I have resources, I don't have resources. Maybe you do have some resources. Then you're like, do I want an in-person program or do I want, an online program? Depending on, maybe you're a working person or maybe you're a recent graduate. If you're a recent graduate, you would immediately go to, okay, I have a bit of some money. I'm also looking for a program that I can be able to spend maybe a whole day or full time working on. So you could look at now resources or, programs which would allow you to get the whole sort of fundamentals. So it could be either maybe a coding boot camp, it could be both online or offline, which require you to immerse yourself full time. If you don't have that much time, you could always think of, okay, I have money, but I don't have full time. You look for courses which are available in the local institutions. There are quite a number of them in Nairobi. There's for persons who are willing to learn data science, there are quite a number of colleges which have those programs. But still, while you do understand that, when you understand that these courses will not necessarily help you to become a good data scientist, what will help you become a good data scientist is you working on projects. If you're not able to work on a project, then an organization won't see the value that you're bringing to them. So the first thing is just work on projects and have sort of stakeholders who you're going to present, those projects, the outcomes of your projects to, so that they can be able to, give you feedback, and they would sort of give you a sort of a feel of, okay, maybe as a data scientist, or you have already provided them a good solution, or maybe not. If you haven't provided them a good solution, it means maybe you still have some more time to spend in learning. So in terms, I normally don't really tell people like this is this book that you'll be able to use in order to learn, because I realize that there are lots of resources that can be helpful, which are online, and some of them are free. But when it comes to you getting the value that you need from those resources, it's usually minimal. So most of the times it's usually like, you just sit down, figure out what you want, know that the program will not give you everything, but what will give you everything is just working on projects. Once you work on projects, you create a portfolio, or which is a collection of those projects, and you can apply to jobs. And when you apply to jobs, some processes, which recruitment processes, require you to do a sort of a job. They allow you to do a project in the recruitment phase to determine whether you can be able to work for them, because those projects are majorly what actually they're hiring you to do. So So most of the times, just work on projects. If you don't know what to start, look for hackathon, data hackathons. It could be Zindi, it could be Zindi.Africa for most of us. It could be Kaggle. It could be, there are tons of resources out there that you will be able to use in order to learn data science. If you're not sure about maybe those places, you could also look for programs which also have projects. So you're learning fundamentals, but also you're implementing. A project is what is going to get you a job as a data scientist and start you that career that you really want. And that is what most of the times you need to do.
Thank you so much for that. So there's a question after
Yes.
you gain the skills and you've
Yes.
done projects. How do you know that you're now market ready? You're now ready to go and apply for jobs, apply for opportunities? How?
Yeah. I would say if you work on a project and you present it to stakeholders and they approve and they say, this is what we were looking for, then you're sort of already a data scientist to an extent, because you're already solving a problem through the use of data analytics sort of methodologies, and that is the point where you say, okay, I am able to transfer my data science skills in solving problems for stakeholders who are actually satisfied. If you just learn, if you go online and go to one of these websites, there are quite a number of them. DataQuest, DataCamp, all those ones, and you don't apply those skills in a project, then still you won't feel, it hasn't gotten to a point where you'll know that you already gotten to become a data scientist. It's until, and it's a sort of it's a feeling that you get once you're able to solve a problem for an organization. You'll feel it and you'll know that, okay, I'm actually learning something. But you will never get there, because every day there's always something new to learn. And if you do explore the field of data science, there are different kinds of problems that you'll solve. There are sort of, if you go for a business, there's customer segmentation problems, which you'll solve probably with something of clustering methodologies, like K-means or hierarchical clustering, or all those. If you go to some certain businesses, they have probably modeling problems that they face. If you're able to solve that within that context, then it means you are already taking that role as a data scientist. Maybe in certain situations, actually, if you go to another context of, especially within the local market in Kenya, where you have many businesses in that not really mature stage, they're starting off to use the data that they have archived, and you go into that organization and you help them sort of create, help them get insights from their data, which is basically data analysis. There's a bit of some business intelligence involved. You use maybe you don't even go into the complexities of modeling or machine learning. You just use the basic descriptive statistics sort of knowledge that you have to create some good data reports. Then you're still a data scientist. Actually, most of the jobs within the local context, that's in Kenya, look for data scientists who can be able to go into what they have in terms of data and can present insights. And that is what you'd say, okay, I am actually being able to do something if I can be able to solve a problem for an organization. It does not mean if you can just sit down and create a machine learning algorithm and still it does not, the outcome of that does not help a stakeholder, then what's the need? Because machine learning is there, and data science is there as a whole for the help of solving problems for organizations.
Thank you. So there's a question.
Yes.
I'm currently undertaking a course in Udemy in data science using Python.
Yes.
I've also been practicing using R over the past 6 months. What is the next step there?
I think it ties up to the previous question, which was still with regards to if 6 months maybe you've started working on a project or a few projects. I think one of the things that would come into, just step up the game. You've learned R, but you now need to put it into an industry context. Look for opportunities which will help you move on from that sort of beginner sort of stage into a more of a challenging environment where you'll have to learn different tools in order to help solve for problems. So you could look maybe for opportunities, maybe junior data scientists opportunities, maybe data analyst opportunities. Try and look for those opportunities. They don't have to be paid opportunities. You could even start volunteering for NGOs, which probably are looking for data within your networks, and you'll find some. Just go to LinkedIn and look out for persons that you think you would who would help probably you and with projects which you can do within that particular domain that you would wish to work for. So my guess is, just step a notch higher. It's just a matter of practice, and the way you practice is through the use of projects. And I think one of the things that usually lacks, and there's a gap within the market, is that gap of, where can I be able to get these projects? The projects can be in Zindi, or as mentioned in those hackathons, but there's still a gap, I think, that can be explored by many providers who provide maybe learning experiences where they could look at people need to learn, and the best way to learn is through projects. How can we be able to come up with a solution which provides projects? So I think that's the best way to go. That's what I think would be the best, because after a year, once you've worked maybe as a data analyst, as a junior data analyst, or even an internship, an organization will probably see the value in what you're doing and sort of give you bigger responsibilities, which could be now maybe offering you a full-time position, which would involve, depending on the organization, now trying to assess the entire business, trying to understand what exactly the business is doing, seeing where you can be able to source data as a data scientist or data analyst in an effort to ensure that the business continues to grow.
I think you've answered this question, but
Yeah.
if you have anything you can add on it. What are the opportunities for data scientists, job opportunities, and any other apart? You've mentioned hackathons and platforms such as Zindi, Kaggle. What other opportunities are there?
Yeah, so as a data there's so many opportunities. I think there was a time when you look in the media, local media, they would say being, there are those jobs which haven't been created yet. And now they're saying that institutions need to prepare people for those jobs that haven't been created. Within our local context, because that's in Kenya, we are at a stage where lots of organizations, they keep on storing data, whether it's hospitals where they just collect data, they store it. Whether it's small SMEs, they just collect the data and store it. And they could even be storing it maybe in just simple Excel files, or to an extent, even if it's more, maybe MySQL databases or Postgres databases, but they don't use it as much. It's a matter of just storing the data and retrieving it for just simple procedures. And I would say with regards, it's more of job opportunities. Could be becoming as simple as a junior data analyst if you're starting out, or junior data scientist, or becoming a data analyst, business analyst. It depends. It varies also with businesses. Sometimes businesses can have the same titles, but certain titles, but you end up doing the same thing. It could be machine learning engineers in some other context, but those are not quite yet. We haven't gotten to a point where lots of organizations require machine learning algorithms, not unless you have an organization that primarily provides a solution for for their clients through the use of machine learning applications, then you could say maybe there are a few machine learning engineers, job opportunities. There are also data scientist opportunities which you could find, but most of them I think require some some experience, quite an extensive, maybe 5 years when you become maybe a senior data scientist. Some of them are even some opportunities are open, and what you do is just work towards that in the long run and set your mind. This is data science, and this is this is the field or the domain that I want to stay in for quite a bit of some time, and maybe for 10, 20 years or 15 years, until it gets to a point where you realize, okay, maybe having a career shift or moving on into a managerial position, still within the same domain, or where you head the data science department, or you become part of the C-suite. It varies. There are lots of opportunities, and they just vary from organization to organization.
Okay, thank you so much. So you've talked about data visualization.
Yes.
So there's a question: how
Yeah.
do you create heat maps using Seaborn and Tableau given the data?
So heat maps. Given, maybe can you repeat the final bits about it?
Given pivot data.
Pivot data. Yeah, so with regards to pivot data is maybe that question is a bit ish, but pivot data is data that you get as a result of summarized data from a larger data set. Assuming that you had these participants within this call data, so you had participants' information about where they live, say how much they earn, how much they spend on food, how much they spend on internet. A pivot data would allow you to maybe do a sum of the persons where they live. It could be areas in Nairobi and how much is spent. But the pivot table would basically be a summary of the some of the aspects that you're looking at the bigger data set. So I would say I'm not sure what it means. How can you be able to use heat maps with Seaborn and Tableau?
Yeah.
Yeah, so heat maps are basically visual representations of that use sort of color codes. If assuming that you had data from 0 with data points from 0 to 1, let's say 0 to 50, you had 0, you had 10, then you had 25, you had 50. Just to give more explanation, a heat map would help you to visualize those data points within a sort of color code sort of range. So you'd have what's 0, it's a light sort of color, but what's 50, it's a really, really intense color. So if you do get a pivot table which has a summary of your data, and you sort of arrange the data in ascending or sort the data in ascending or descending order, you could always use heat maps to specify the top 3, or maybe the top, the most, the data point to just highlight the data point with the highest intensity and the one with the lowest intensity. I think it's much more useful when you have a pivot table with a lot of data, especially in terms of the columns. So if you are comparing different records, you'd use a heat map to highlight the data points which are of higher intensity. So if you're presenting some sort of visualization, maybe about an analysis of what we have said about, let's say, the data of the webinar, or with the data that you've collected, you would say, okay, the persons with the most, the areas with the most, the most spent in terms of cost for maybe something, you would show it with a heat map. This is the top, and the one with the most, and the one with the least. So it's, I don't know how to explain it clearly, completely, but I think maybe you do get the idea. A heat map, it just helps you to visualize data points, the magnitude of data points through the use of color, and it's usually from maybe the light color to the darker color, but it varies. It could be blue, black, red, yellow, green, orange. So it varies. How do you use it specifically? Like, the code itself, that I would tell you just to Google. I don't even keep, I don't memorize code or, anything, or those procedures on Tableau. What I do is, you could go to the documentation and look at that. But heat maps are fairly easy to implement. SNS.heatmap or something. Yeah, I think of the sort. I think that would work. Yeah, just Google it for an implementation and use. There's something that usually happens is that, as I've said, the most important thing is that you solve the problem for a stakeholder, even if it means you're not really sure, because you are not taught about how to use heat maps in Tableau. Just Google and you'll get how to do that. Same case with Seaborn. Maybe you are taught to use heat maps with something like, is it Matplotlib? Yeah, something like Matplotlib or Plotly or whatever. Just Google, you'll get your solutions once you do that.
Okay, thank you. So the next question is about how do you incorporate data science with web and mobile application? How do the two combine the tools?
So so most of when it comes to web, normally this is usually the infrastructure that's used to collect data. Same case with mobile. Across many organizations, you would have an organization, they have a simple web application where the person behind collects data, maybe for registration, maybe it's a hospital, for registering patients. If you go to the field for persons who are in research, they have persons who would go to the field and collect data and input that data in simple mobile applications on mobile phones. Still, you could be able to use these web applications as maybe dashboards where behind the scenes of what of the whole thing, maybe at the back end of that application where the data is stored, you could have certain operations which help in terms of maybe performing a certain analysis or even doing some modeling and presenting the insights on a dashboard. There are quite a number of organizations. I know of Ajua, which also the M-Survey one, Ajua, which also collect data from what they do, from questionnaires, from surveys, and they output the result of, say, clustering analysis, which is or text analysis, because they collect data from customers who have already purchased products from organizations. So once they collect that data, they pass it through some text classification modeling algorithms, which sort of pick out the major themes, which is maybe the customer wasn't satisfied, you need to fix maybe wait time, maybe the food was not hot, like all those. It collects all those themes and it presents them to a dashboard, which is a dashboard is basically, you could think of it as just a web application with insights where the stakeholder can be able to see. So that's another way of doing it. You could also do it with I think another way of, I think, yeah, those are the best ways of sort of working around using mobile and web development applications. I think if it's usually simple. If you type, I've forgotten. I think there's a certain service by Google or any dashboard or whatsoever. Like, let's say Google Analytics. What they usually do is that they collect data about whether persons have gone to your websites, the pages that they've visited. So once that data is collected, it's showed it's shown to persons who are using analytics, Google Analytics. It shows the results of, okay, these are the people who are using, this is the time that they came into the website. It shows a bit of even some more specific aspects of analytics, which is more of, how long, this person stayed. I think there's even some conversion sort of time, but there's a lot that happens. You could be able to just implement it through just web applications, and by that it could be, just to get into the tech bit of it, you might decide to create models. Models are, if you think about it, Python code or R code you create, and which usually takes in input and comes out with an output. When it brings out the output, you could sort of create what is in web development, REST APIs, which would take the output and pass it through some other functions, and which probably would do some statistical analysis, and the output of that can be able to be retrieved from a REST analysis, the RESTful API, which can be used. Maybe you could look at tools like think Flask. You could also be able to use other tools which can help you be able to create those REST APIs. But it's a whole lot of, if you're a data scientist, sometimes data scientists usually are involved from the very beginning. How they can be able to create systems which collect data, analyze, model, and also deploy data. But in some organizations, they even have teams. Like there's a team which handles, the analysis, the collection of data. There's the team that's involved in the analysis and the modeling of it, and there's a team that's involved in the production of in the deployment. That's the model production of the data science aspect of that. Yes.
Thank you. Before we continue, is there anyone who has any question so far? Anyone with any question?
Okay, tell us about web scraping as a way of collecting data.
Oh, yeah. So web scraping is a function. It's a way of collecting data from websites, and how a good example would be if I'll just use a common website. Assuming that you wanted to collect data from iHub, the iHub website on jobs. You wanted to collect data from another website that offers data. Maybe it's the Star, which also has data on jobs. You also wanted to collect data maybe from all the websites within, let's say, Nairobi, which offer job opportunities, and you wanted to collect all of that data. You could be able to use web scraping, which is more of a concept like, to an extent, maybe it's another concept like modeling, but now this allows you to just collect data from different sort of sources, web sources. And how you would do that is you would specify within this particular website. If you're a web developer, you could see how maybe a website is basically a series of web pages. And when you scrape data, you would refer to what are the elements within those web pages, and you get data from those elements. So you would create sort of code that allows you to select data, take data from this particular website. The same case, you would create code, another kind of code to be able to select data from a different website. The reason why you'd be able to, you have to create different sorts of chunks of code is because maybe it's, the architecture, the way websites have been designed are sort of, it's different. So once you do that, once you retrieve the data, you then store it in a sort of a standard way, in a standard format that could allow you to further analyze or further offer another product. I would say maybe if you wanted to maybe do just a good example to do a project on web scraping, I've never thought of that, but my focus is majorly on data science and creating learning experiences. But you can be able to, assuming that in Nairobi you have so many classified websites, the websites that offer just products from different, from different vendors. It could be gg.co.k, it could be olx.co.k, pgme.co.k. Fine, you figure out how to also get data from jumia.co.k. Once you get all that data, that's products that are sold from those different websites, you bring it to one sort of I'm assuming a web application where you now sort of do your own analysis, and maybe you provide another product. So ideally, you could use web scraping to source for data across different websites and create a sort of a different product. But you could also use web scraping to get insights, because that's what's most important. That's the reason why you have web scraping. You need data, but you don't want to go and collect data manually. So you sort of create programmable code that allows you to select data from different sources. So web scraping, but there are of course limitations when it comes to web scraping. You could have some websites require you to log in, which web scraping does not help you it does not help you, because it usually if a website is open and there's any sort of authentication, then it allows you to, then you can web scrape any website. But if there are sort of blocks, then unfortunately you would have to resort to other means aside from web scraping.
Okay. Any other person with a question?
So actually, is it legal as a data mining technique?
Yeah, I think it's legal, but you have to look at the regulations, especially when you're working as a data scientist. There's the ethics in data aspects of your practice, and they're governed by different laws. In Kenya, there's the data law that came out some other time, which states that while you're collecting data from different sources, the data can be deleted. It has to be deleted. It has to be stored for a certain period of time. You cannot be able to keep it for afterwards. If someone tells you delete that particular piece of data, you have to delete it. So it varies with different jurisdictions across various contexts. I think for a start, you could just I think it's fine. It's open in the web, but it's always good to ensure that you get some consent before collecting that data, because you might end up collecting personally identifiable information. I think it's PII, which you would if you misuse it or somehow without any ill intention, the data gets misused by other parties, then it could get you in trouble with those laws within those local jurisdictions or those jurisdictions. So there are those aspects that you have to consider. You could do it for the intention of doing that, but you always ensure that you involve all the parties, all the stakeholders in that process. I think one of the things that some web scraping projects would create value for all stakeholders, which is fine, and you could always ensure that you do that. It's an aspect that you can't ignore. If you ignore, it will come back to you, and when it comes back to you as a data scientist, then it becomes something that could end up damaging your reputation, which you wouldn't want. Yep, I think that's it. Any more questions?
Any other person with a question?
Hello.
Yes.
Hi.
Hi. So my question is with the rising applications of AutoML, how does it AutoML tools like H2O.ai?
Mm-hmm.
How does it leave data science? Are we left with the thinking part? Maybe you had explained it with the thinking or the workflow of how the whole process will be done, because sometimes it's like done for us. So using those tools. So how does that leave us as data scientists in the industry?
So I think one of the things that I would have wanted to share with you, but unfortunately I'm using the web version of Teams. I wouldn't have been able to share with you, is a document that basically provides an approach that you can use while working on your data science project. Sorry about the noise. So while you're working on any data science project, there is what is called an industry standard methodology. And the most popular one, one of the most popular ones, well, it's not the most, but it's one of the most popular ones, is called CRISP-DM. And it highlights the steps that you need to take while working on any data science project. The first step is usually business understanding. The second step is usually data understanding. The third step, data preparation. Then fourth step, modeling. Then fifth step, deployment. It varies how these steps are looked at in various situations, where you have maybe an organization doesn't need modeling, it just needs analysis. So analysis at that stage, or doesn't need deployment, it just needs you to present data. So that's also part of deployment. I think in terms of those tools, the automated tools that you've mentioned, the idea of them coming into or taking the jobs of maybe the roles of data scientists, I don't think they would be able to take them per se. Maybe data scientists can use those tools to help them solve for the problems that they need. Because a data scientist, from the start of a project, they would need, first of all, to understand the business. What is this problem that the business team is looking towards solving? Sometimes, a good example would be a business person might want to, or a business stakeholder might want to just they say, okay, we from our previous sales in our last month, we were able to reach out to these customers. Can you help out? Help us solve. Can you help us with your data knowledge in order to figure out how we can be able to reach out to a bigger customer base? And when you look at that problem, you'd be like, okay, maybe it could be that they want to understand the customers better. That is, sort of have an overview of who their persona is as a customer, and also sort of get a sort of customer segmentation, sort of an analysis that would allow them to spend resources on the most return of investment customers, the customers who would pay the most, and stop focusing on the customers who pay the least. So that step would be would involve a data scientist working on that. So the idea that a data scientist is someone who gets just data and start working on a problem, not really. It doesn't start like that. You have to start from the business, really understanding the business, because actually it might not be that the business person wants to solve for figuring out the customer segmentation. Maybe they want to forecast something. Maybe they just want to get an analysis of the work that they have done. So it's a matter of, first of all, understanding the business, the domain really well, and the factors that influence a lot of business decisions. Then from there, once you've been able to understand your business clearly, you're now moving into sourcing for data, which it wouldn't be that machines would be able, or those automated tools will be able to solve for that. It requires some sort of human intervention. Sourcing for data, determining whether the data that you have is the correct data to help you solve the problem that you had. It could be also performing, well, there are automated tools which do perform data cleaning and data preparation aspects, but also trying to link whether can I be able to source for some other kind of data from somewhere else in order to to solve for the problem that they have. And that relies majorly on the domain knowledge that a data scientist will have. Once you do that, you go into the data preparation stage where an automated tool will find clean data, but still within the process of cleaning data, there are still some critical decisions to be made. For example, an automated tool might delete all the data with missing records, and you as a data scientist would, if you were to perform the analysis, you would need probably to perform some sort of imputation method, maybe some regression method. Could be that the machine learning the automated tool might decide to do vice versa, or maybe they might do the same. So there's always some sort of supervision that would be required to happen in certain cases, in most of the cases. But you never know. In a few years, maybe 10, 20 years, some of these decisions that data scientists usually make could essentially be possible by automated tools or learning applications or programs which would essentially become better at doing that. I would say maybe for the time being, we haven't gotten to a point where we can be able to do that. But in the near future, it's always best to keep open to such kinds of developments within the field of data science, especially in research. And if they do happen, if there's a data scientist, what would happen maybe would be sort of getting those tools and using them within that that data science process, but with a lot of supervision in ensuring that those automated tools are able to perform what a data scientist intends to. And it will take time, especially maybe in fields where a lot of decisions are quite critical. Maybe in the medicine field, where you need to ensure that whatever analysis that you're getting from your data is the correct one, because it could influence whether maybe a patient lives or die. So there's a lot that will have to happen in order for that step to happen.
Thank you for that. So we have questions on machine learning.
Yeah.
The first one is, where can I start if I want to get into machine learning, and what mathematical topics should I cover?
I think the most important thing is that if you're starting to learn machine learning, don't even go straight to machine learning. Like, as I had mentioned, first of all, understand how to work on the basic concepts of working with data. They're just basics. If you're given a data set, where do you even start? How do you first of all clean it? Yeah. So first, not even cleaning it, how do you read the data? How do you read data? How do you source it? How do you explore it? How do you clean it? How do you prepare it? So once you've been able to grasp those concepts, you can now move on into the more advanced topics of now getting into now modeling, which not so many problems will help. Not all problems in data science are modeling problems, but a subset of data science problems would entail modeling, which you can now be able to go into that. I would say quite a number of platforms that would allow you to do that. To learn how to model. It could be starting out with even Kaggle. Kaggle has courses on machine learning, just getting the basic machine learning algorithms. Could be KNN for classification and also for regression, and solve a problem, just a small problem. Then work on understand and how to use another one. Understand the sort of theory behind those algorithms, then apply, try and also work on small problems. So I would say maybe Kaggle. There's analytics video, which also gives you a few sort of tutorials on how to go about it. If maybe you want to pay, you have a bit of some cash you'd want to pay, maybe you could just enroll for online courses which are paid for, and not necessarily these exorbitant ones, but just the ones for even, I think, $5 a month or $10 a month, and you ensure that you have a goal that you want to always look towards. So once you go through that, then the boom. Oh, I think there's even Coursera, there's Udemy, there's Udacity, quite a number, and there are many of them which are coming up. Or you could even go to the the community workshops that we usually hold, the AfterWork community workshops on Meetup, that usually happen almost every Saturday. So yeah, and if you still have money, come for the AfterWork Data Science program and learn data science. So yeah.
Yeah, you should actually apply for the AfterWork program. So the other question is, how long will it take you to be considered as a junior machine learning developer? So the person who's asking is a software engineering student.
Oh, so I would say if you were to use the path of you become a junior data scientist, then after becoming a junior data scientist, maybe you go into becoming or junior data analyst, you go into data analyst. I think maybe then you go into becoming a data scientist, then a senior data scientist. Maybe now after that you become a person who's it's the managerial level. Maybe for the first 3 months you could start at an internship level, data science intern. Then after maybe 6 months, after those months you apply maybe for a role that takes you a whole year as a junior data scientist. Could even be 1 to 2 years. You never know. The organizations are different. Then after that, you could even apply to become a data analyst or a junior. Just a data analyst or a data scientist. At that, it would be maybe towards your second year. Then after 2 years, 2 to 5 years, that's you becoming just a data scientist. But in other contexts, they're usually just data analyst. Once you become a data scientist, you can also move on into senior data scientist, maybe after 5 years to 8 years. Then after that, you're now moving into managerial level, you move into managerial level where you can become maybe a director of data or director in an organization, or a head of a big department in an organization. Then maybe later onwards you become, maybe after maybe 10, 12, 15 years, a CTO of a big maybe company or multinational. But it really varies with the opportunities that come along. So if you wanted to become a data scientist, maybe 2-3 years in order for you to be referred to as a data scientist in a company. But while you're starting out, just use the opportunities of being a junior data scientist, or maybe being an intern in order to get into that position. But there are also persons who are not starting out, they're already working, and they would also want to get into data, and not really at that level where you really interact with code and work on code itself, but they want to get to the point where they want to manage teams, maybe becoming a data manager. That's also possible, which might not, it could come from maybe you are an IT manager, you wanted now to shift towards data scientist, becoming a data scientist. That's also possible. It's just a matter of now just ensuring that you're able to fully understand the processes that entail when it comes to handling data projects, and how to implement them in an organization, and how to manage a team, a data science data science team mainly.
Okay, thank you. So the other question is, which is the best cloud platform for data science or machine learning? I'll say Azure, but let's hear from you.
So there are quite a number of platforms. There's IBM Studio, there's AWS SageMaker, there's Azure. I think for persons who are not, maybe conversant with languages, the programming languages, you could try those tools that just allow you to drag and drop. The likes of Azure, the likes of, there's even, if you use AWS, there's also SageMaker, but SageMaker is a bit, so there are different platforms. There's even a IBM Studio. So it depends on the tool. Again, whatever tool that you think would help you do the job at the moment is the best tool. And also the kind of probably data that you have, or the platforms that you're using, and the resources that you have. Maybe you work in an institution or company where the tools that are available are, are more towards, are within the ecosystem of maybe Microsoft. One that really makes sense to invest more in could be Azure, as opposed to moving on into another different kind of a platform. If it's maybe an organization that uses AWS for almost all the products that they have within the organization, maybe for web development, for other software engineering roles, for storage of data, moving into that. You can now start looking at tools which are within that ecosystem, because of, first of all, learning within one ecosystem, it's easy, and also applications tend to be easier to integrate, to work with, especially with they're in one particular ecosystem, because the stakeholders, which the owners of those ecosystem have made it easier for ease of work, as opposed to you shifting from, let's say you have a product which collects data on AWS. Now you need to connect it to some some service in Asia. Then you would need to have to you do a lot of work of, maybe if you're not quite well conversant in that, you need to do a lot of research. Once you do a lot of research, I don't know, I think it's best to just work with the tools that you have and assess whether they do make sense maybe to work with.
The other question was your opinion about IBM Watson.
Yeah, I think this one was also covered almost in that question.
Yeah. So the other question, I think this will be the last one. So let's say you're new to data science, so you have the background in data science. How do you transition? Maybe you're doing marketing or anything else. So how do you transition from your current job or your current course or whatever you're currently doing in data science?
I'd said projects, because projects are the best way for you to learn. Identify problems which you can be able to solve with data, and once you do that, take a stab at those problems by working on those problems and seeing whether you can be able to provide solutions with those solutions to those projects. So my thinking would be, use, as I mentioned, all the tools that you think would work best for you. Maybe you are good at Python, and you grasped Python a long time ago, and right now you are at a managerial level. You must have forgotten how to use Python, but you are good at Excel, and it comes to a point where you now need to start learning how to how to use tools in data science. I would say just focus on the tools that you have, because the concepts are usually the same across different platforms. You might be surprised that even performing some kinds of modeling, it's possible to do that if you use a simple, tool like Excel. But of course, there are limitations which would ensure, maybe would force you to now start looking at, okay, maybe I can be able to use Python or R. But when it comes to that decision, you're like, I've ever learned how to use Python, it would just be easier for me to do that. So you're moving into that. So it's just a matter of use what you think you can leverage while you're working on projects as a way of starting out in this field. So yeah, that's my thoughts on that.
Okay, thank you so much. Anyone with any other question?
So actually in ML, there's a lot of algorithms. So what the best way to master them all?
Okay, so initially when you're starting out, they're quite basic. There are quite a number of basic ones. And in machine learning, you would be working on maybe two kinds of problems: classification problems or regression problems. For classification, you could look at things like, algorithms like logistic regression. It could be KNN, that's K nearest neighbors. It could be, I think, naive Bayes. It could be decision trees. So just understand how those algorithms work, because most of the times you realize that even those ones do the job for you. They might, if you're able to sort of feature engineer your whole project right, in terms of getting the right data for that particular model that you're using, be it those of a few models, you would get the best output in terms of maybe the right predictions with a better accuracy, with the most, not the best accuracy, but the most acceptable accuracy, because you can never have a 99%. If you have a 99%, maybe it means that you have to think about whether your model is fitting in the data, which, in terms of fitting in, it's usually of, okay, is my model able to work well with only just the data that it was trained with, or is it able to work well with new data? So it's a much, just learn the basic ones. When it comes to regression, also just, they're not many, maybe there could be 5 to maybe 8 of them. Once you learn how to use those ones, then you can now be able to use other kinds of regression algorithms or classification algorithms after you've resolved that the accuracy that you are, let's say, aiming for has not been achieved. You can now look at other fairly complex, but you will have to read. I think one of the things that I noted when you're starting out, and also when you're working on projects, you'll sort of get into this journey of research and research and research. Fine, the basics, but according to according to recent developments, there are other algorithms. It could be XBoost, it could be other ensemble learning techniques, the likes of random forest, and I think it's just a matter of just learn the basic ones, because the basic ones will help you out. And if not, then do research. Or there's an easier way, which is okay. There was someone who had mentioned about AutoML tools which are available in the market. And you could even go to a platform like Azure, or even AWS SageMaker. And those things, when you put in your data, they'll just immediately, they usually have proprietary algorithms, machine learning algorithms, which will help you in your analysis. When you put your data like this, they'll they'll eliminate all the models that you don't that are not showing the best output, and give you the best they give you the best models, which may be proprietary, but from then on you can now start working on on fine tuning your parameters, and also working on your maybe feature engineering, applying the domain knowledge that you need in order to further enhance your algorithm. So it's a matter of just get the basics. Once you get the basics, you'll be able to learn. But there's one question I just remembered I hadn't answered, which was with regards to stats. A lot of the learning, what's behind the models is usually tons of statistics and mathematics. And I think if you come from maths and stats background, sometimes you usually find understanding the concepts behind the model a bit easier, because they rely on knowledge that probably you learned in the past. It could be linear algebra, calculus, a lot of differential calculus. So just being able to understand what happens under the hood allows you also to sort of fine-tune those models, because in your mind, while you are sort of applying the right parameters, in your mind, you'd be always thinking in abstract terms. If I do this, then it means parameters C and D would need to be reduced to a certain level, because in this scenario, our assumptions are A, B, C, D. So there's a lot that you'd need to learn behind the scenes. And the resource to start working on that, look at brilliant.org. They have really good tutorials on how to, on the basics that you need. You'd need probably, of course, you'd need differential statistics and inferential statistics. Differential is like the basics of, let's say, if you wanted to do just a summary of a data set, you'd get mean, mode, interquartile range, standard deviation, like all of that is a differential, but inferential is now where you now need to make predictions, which would now go into what you'd use while you're working with models. Yep. Are we good now? Hello, I can't hear you. Maybe if there's any other question, is there any other question?
Is there anyone else with a question?
I think we're good then.
Maybe you can add anything else, conclusion.
Okay. I think the most important thing, as I had mentioned, is if you are starting out in this field, is to work on projects. And the best way is to look for learning experiences which would incorporate the aspects of maybe fundamentals and also projects, because projects are the ones that are going to help you learn and solve problems for different stakeholders. If you do get opportunities to present, those projects to different stakeholders, or maybe those programs that you get are sort of blended with what's happening in the industry. Some of the business problems that you get are straight from industry experts, then you'll be at a position to learn more because you are getting the right feedback. A lot of the programs that you'll get are majorly academic oriented, which may to an extent provide you with the fundamentals, but they leave you out to explore by yourself. So the best way is to always look for projects which that if you are to present, you'd get quite you'd get quite good feedback on that. So yeah, I'm always open to any chat in terms of how we can be able to develop the ecosystem, especially when it comes to data science, and how people can be able to learn the different approaches or sort of activities. And I'm always open, and could always reach out to me on LinkedIn. And if you're also thinking towards maybe going into a learning experience, you're in the field, you're still a professional, and you would want to to do something of the sort or learn data science, you could always apply for the AfterWork data science program, and you will be able to learn a few things here and there, because that program is tailored for persons who are working. Other than that, I hope to see you in the community workshops, and thanks so much for asking questions. It shows that this ecosystem is growing and people are willing to start using data in an effort to help organizations meet their goals. Thanks a lot.
Thank you so much. There was a question that people asked about how do you get employed in Microsoft as a ML engineer or a data scientist. That question, in Kenya currently, there's the Africa Development Center. It's only hiring software engineers, but it will come up, develop in the near future. But for any job related to Microsoft, you can go to careers.microsoft.com and search for whichever job you want. And for instance, for machine learning, you can search machine learning, check the prerequisites, check what they need, and then try and align yourself to where you want to be. Yeah, I think that's all. Thank you so much, Valentine, for coming today. And thank you everyone for joining. We will meet again probably next week for another session. So thank you all for joining.
All right. Thank you too.